Okay, my name is Yona from Kwa University College of Education.
Okay. Hello, my name is Ezekiel from University.
Hello, my name is Elias, a physics mathematics teacher from University College of Education. Okay, now we are going to discuss on the Lorentz theorem and series, and we are going to look on its application, that is length contraction. Now, on this length contraction, we are going to look how now the space and time adjust differently to different observers. Now, the length contraction occur because the space and time adjust between observers, so that the speed of light remain what? Constant. An object is moving towards the tunnel. Between two observers, one observer see that the length of an object becomes shorter as approaching to the tunnel. What does it mean? We have an object moving toward the tunnel, and we have two observers. The first observer will see that when this object is approaching the tunnel, its length becomes shorter, while the other observer observes that its length of this an object coming to the tunnel, it is the normal or the property length. Mathematically, the observed length is given by the ratio of an object at rest over the Lorentz factor, which is L is equal to L naught over this Lorentz factor. But the Lorentz factor, it is given by this formula. Now, we want to see this amplification. What does it mean? This L naught, it is the length of an object at rest. L means the length measured by the moving observer. V is the speed of an object moving toward the tunnel, and this C is the speed of light. So, from this formula, it is going to be observed that this L, which is the observed length, is going to be less than the length of a moving object at rest. And let us now see the application of this Lorentz theorem and theories on the length contraction in daily life situation. This now, as you can see in floating, it is a real life application of Lorentz theorem and theories, specifically on the length contraction. How? As you can see here, we have a tunnel here, and also we have an object moving, which is a train. Now, as we have observed from the theory, on the Lorentz theorem and series, specifically on the length contraction. Now, this train now, let me assume have length L naught from here up to here, downward. The length L naught. So now, and let me assume we have two observers. The first observer, it is near the tunnel, and the second observer is on the inside the train. Now, we want to observe how the space and time adjusting differently to different two observers. The observer near the tunnel, and the second observer is inside the train. Now, look, starting with the first case, let me assume the first observer is inside the tunnel, inside the train. This observer inside the train, as the train is moving toward the tunnel, he or she will observe that this length of the train is greater than the length of this tunnel, and now the train cannot move inside this tunnel. That is the first case. Coming to the second case. Now, where now the observer now is near the tunnel. And remember, as we have said on the theory, that before this now train starting to move, that is at rest, its length, it is L naught. But as now this train starts to move, the observer near the tunnel will observe that its length decreases as it is approaching Now, from these two cases, which now observer is correct? The first case maybe, or the second case? Referring to the length contraction, both these two observers, they are correct because space and time adjust differently to two different observers. Thank you.